In the previous lessons, you learned how to set up the flowchart based on the given and the unknown, and you start from your given all the way to solve for your unknown. Now, so far, you only learn how to copy the conversion factors directly from flowchart. The conversion factor for molar mass is basically 1 moles of A equal to the number of grams of A. In this case, we are going to look at how to get that number of grams right there. And of course, we use the letter A, that's to represent the chemical. But one thing we need to know for sure, it is relative to 1 mole. So that's very important. The molar mass is equal to 1 mole of that substance. For example, okay, what is the molar mass conversion factor for 2H3O plus? If you notice the 2 in front of H3O plus, that tells you there are 2 moles of H3O plus. So we need to get rid of that and rewrite this as H3O plus. Now this is now 1 mole. So how would you find the number of grams? Well, to find the number of grams, you have learned how to Google for the molar mass, but it is really easy to find the number of grams using the periodic table. If you look at this compound has how many hydrogen in it? Well, that 3 tell you there are 3 hydrogen. What about the oxygen? Well, the oxygen doesn't have a subscript or any number down here. It indicates there is only 1. And all you do is find the mass on the periodic table. For hydrogen, each one of the hydrogen is 1.01. So the total mass for hydrogen is 3 times 1.01 for the formula H3O plus. So if we plug this in the calculator, 3.03. Now for oxygen, if you look right here, 1 moles of oxygen on the periodic table, it is 16.00. So now you have 16.00. So what is the total mass of chemical A? So this could be the chemical A. So this is the chemical formula that's represented by the letter A. So we just add them up, and this gives us 19.03. And that would be the number of grams that go right there. Now, to write this as a conversion factor, we would do the same thing. The exact format. Of course, 1 moles of A, notice how I abbreviate mole, equal to the number of grams of A. Now what's A again? A is your H3O plus, and again H3O plus, and what is that number of grams going to be? It's going to be equal to 19.03. And there you go. That's all you have to do to get your molar mass conversion factor. Let me write this nice and neat again for you. 1 moles of H3O plus, and if we are to type this on Streamline Ed, we use the caret symbol to represent the charges, and the number of gram is 19.03 grams, which is represented by G, H3O plus, caret symbol right there. That caret indicates the charges. And that's all you have to do. Let's try another problem. In this case, I have a more complicated compound. And again, that 4 right there is irrelevant because we are looking for 1 moles of the substance. So what we're going to focus on is just calcium nitrate, NO3. There you go. Now, if we look at this, okay, how many calcium do we have in this compound? Of course, just 1. How many nitrogen do we have? That 2 right there indicates there are 2 of what's inside the parenthesis, which is 2 of NO3. Basically saying in a mathematical term, you take the subscript and time each other. What is 2 times 1? So for nitrogen, it's equal to 2. What about for oxygen? Well, oxygen is 2 times 3 and give us 6. So this 6 is equal to 2 times 3. This 2 is equal to 2 times 1. Okay? Now, let's go find the mass on the periodic table. For calcium, it is 40.08, so times 40.08. For nitrogen, it's 14.01, 14.01. And for oxygen is what? It is 16.00. And of course, we're going to plug this into the calculator to find the total mass of each element in this particular compound. And for calcium, it's 1 times 40.08. So the answer is 40.08. But for nitrogen, 2 times 14.02. That is 28.02. But for oxygen, we have 6 of them. So 6 times 16. This gives us 96.00. And to find the total mass of the whole entire chemical, compound, we add all the mass of all the elements together. In this case, we plug in the calculator and we have 164.1. And to write this as a conversion factor, again, it is relative to 1 mole. I'm going to write out the conversion factor and we're going to substitute in, okay? So we have 1 mole of A. Notice how I abbreviate mole, and that's A, equal to the number of grams of A. And what is A again? A is your chemical. It's just basically like X and Y. It represents a certain number. In this case, the letter A represents the chemical formula. So we have CaNO3, parenthesis 2. And over here, the same letter, so it's going to be the same chemical. Again, I just go back directly to my conversion factor and just plug it in. And NO3, 2. What about the total number of grams? That would go right here. That's pretty much it. So let me rewrite how would this be input on Streamline Ed. So 1 mole of CaNO3, 2 equal to 164.10 grams of CaNO3. And of course, why I'm putting 0 there? Because I asked you to type in 2 decimal places. Now let's try again. What is the molar mass conversion factors for 5 moles of NH3? Again, we are looking for 1 mole. Molar mass conversion factor is relative to 1 mole, so we can ignore the 5. So pretty much we are focused on NH3. And for this compound, we can see that it has 1 nitrogen, and for hydrogen, it has 3 hydrogen. And the mass for nitrogen is what? 14.01, okay? And then for hydrogen is 1.01. And now, 1 times 14.01 give us 14.01. And 3 times 1.01, that will give us 3.03. And then all we have to do is add them together. And this gives us 17.04. And to rewrite this as a conversion factor, molar mass conversion factor, I'm going to write it out 1 moles of course, is always 1 mole. That's the definition of conversion factor. It's relative to 1 mole of the chemical A, which in this case I know is NH3, equal to the total mass in gram of NH3, which is 17.04 gram of NH3. And there you go. This would be the molar mass conversion factor for NH3. Now you have find the number of grams in this measurement. We are going to review what we did before, where we have to set up the flowchart so we could combine the 2 concepts together. For example, if a chemical reaction requires 1.7 mole, that would be our given right there. So 1.7 mole, okay? And this is the moles of carbon. How many grams of carbon are needed? So this is your unknown question mark G of carbon. As always, we always start with side A with the chemical and the unit. In this case, we have moles of carbon. And that is basically moles of A. So this is where we're going to start at that particular box. And we are going to solve for what? What are we always ends on? We always ends on the unknown. In this case, is gram. And grams of carbon is basically grams of A. And notice how carbon and carbon are the same. From our given, we are going to multiply to the conversion factor until we get our unknown unit and chemical. In this case, we have moles of A going to grams of carbon, which is the same chemical, and grams right here. So this is where we are going to end. To get from here to there, mole to gram, we multiply by 1 conversion factor. And let's set this up. Of course, we always start from, what are we looking for? Grams of carbon. And then that is equal to, we always start with our given 1.7 mole of carbon. And we time the conversion factor. Notice now I'm just going to copy exactly given to me on the flowchart. 1 mole, and I'll abbreviate it, okay? 1 moles of A equal to the number of grams of A. And what is A in this case? What is the chemical that we're working with? Carbon, of course. The chemical doesn't change. And what's the number of grams of carbon? Can we find the molar mass of carbon? Well, that's easy because carbon just by itself, what's the molar mass of carbon? 12.01. We don't even have to do the math at all. So this answer is 12.01. And if I'm going to rewrite this and multiply my conversion factor, the very first thing that you should do is write down starting from your given. So 1.7 moles of carbon. And time the conversion factor like we did before. Notice how this is moles of carbon. So we look at the measurement where it has moles of carbon. So in this case, we will have 1 moles of carbon. And the number of grams will be on top. So this will be 12.01 grams of carbon. And guess what happened? Moles of carbon cancel out. And what we have is 1.7 times 12.01 grams of carbon. Plug into the calculator. We have 20.42 grams of carbon. And basically that 20.042 right here is going to be right there. There you go. Let's try another problem. If a chemical reaction required 2.3 moles of calcium carbonate, how many grams of calcium carbonate needed? So of course this is our given. And what makes this the given? It has the given number that we can work with. So our given is 2.3 mole, and I'll abbreviate mole, of CaCO3. And we are looking for grams of CaCO3, question mark, grams of CaCO3. So again, we are starting from a given. In this case, the unit is moles of a chemical, and that's where it is. And that's where we start. Okay? And where do we end? Of course, we end where the unit of the unknown, in this case, the same place. So that would be where we are going to end. So going from here to there, which is the same flowchart, okay? And let's see how complicated it's going to get. And of course, we always start from our, what are we looking for? We are looking for grams of calcium carbonate, and equal to, our very first clue is the given, 2.3 mole of CaCO3. Time the conversion factor. In this case, there's only one, which is that one right there. And I'm going to put it right there. 1 mole. Notice how I copy exactly from the flowchart. The only thing is I abbreviate the unit, equal to number of grams of A. And what is A? Why am I using A in the first place? Because they are the same chemical. So this way is CaCO3, CaCO3. And how do I get the number of grams right there? Of course, we have to find the molar mass for it. So let's look at CaCO3. Okay. And in this compound, how many Ca do we have? We have 1 Ca. How many C do we have? 1. And how many O do we have? 3. So what is the mass of calcium? Well, the mass of calcium is right here. So we have that times 40.08. And for carbon, what's carbon? Carbon is right here, 12.01. And this would be times 12.01. And for oxygen, I remember, is 16.00. So in this case, times 16.00. So we have what? 1 times 40.01 is 40.01. So what do we have for calcium? 1 times 40.08 is 40.08. That's easy math. Then we have carbon. 1 times 12.01 is just 12.01. And here it gets tricky. 3 times 16, what is that? Well, of course, it's going to be 48.00. There you go. Isn't that easy? So now we need to total the mass, and we're going to add them all up. That will give us our number of gram in this compound. So again, this is the number of gram in 1 moles of this compound. That's why we add them up, okay? And the answer is 100.09. And this is what the number is going to be, 100.09. There you go. Now, can we rewrite this and simplify by multiplying our conversion factor? Of course you can. So again, the best way to do is starting with your given 2.3 moles of calcium carbonate. And when you multiply your conversion factor, you have moles of calcium carbonate. You're going to have this side going to be on the bottom. It has to be the same. So you have 1 moles of calcium carbonate, and on top will be 100.09 grams of calcium carbonate. And this cancels each other out, and notice what we get. We get 2.3 times 100.09 grams of calcium carbonate, which is exactly what we're looking for, isn't it? And the rest you have to do is just plug in the calculator. And what we have here is 230.21 grams of calcium carbonate. And that number go right there, 230.21 grams. And that's how we use the flowchart with molar mass, using the periodic table.